different different platform. I want to use Sage now and compare with R to see the result of both of them. So we're going to be using Sage. Sage is symmetry and asymmetry in geometric data. So it can be downloaded online. So you can check it online by Eladio Marquez. Alright, so for you to use this Sage is more sophisticated than R when it comes to symmetry and asymmetry. Alright, and it handles both object symmetry and matching symmetry at the same time. Alright, independently. So it's good when it comes to this symmetry, because that is what it is meant for. Okay, that is the only thing it does. It can do more than that. Alright, that is why it's more sophisticated than R when it comes to symmetry. So it handles all the operations at the same time, right? And they present to you all the necessary components that you need for data analysis, and the percentage of each principal component is also presented. Like for example, in R, you will not be able to see the percentage of each PCA, each pieces each warp deformation. You cannot see their percentage in R. The same thing in MorphoJ, you cannot see, but you can see the interface in MorphoJ, the deformation warp in MorphoJ, but you cannot see the percentage produced. So, but you can see here, you can see the percentage. You can also see the deformation warp, which is PCA. All right, so let's see how to work around this. First and foremost, what we need is that we need 3 files for this particular section for object symmetry. We need 3 files. So, like we did before in our previous section, this is our same data. Don't forget our same data. We use face data. We use in R, which is a 2 repeat. So the same thing you can see here. So let me open show. So you can see the same data we use here. So it's still 2 repeat here. We have not changed anything there. All right. So at the same time, we need what is called a ID. It is called ID protocol. All right. Here it is called ID protocol. So just a file name. You can change the file name to whatever you like, but that is the name it is called here. So you can click here to open it now. Let me open it and see what is inside. It's giving you the ID of all the specimens. All right, all the subjects. We have 1, 2, 3, 4, 5, 6, 7. Here it's different from the R. You have to conform with the rules and regulation in each applications. Here we have 1 to 60. Yeah, we also have 1 to 60. All right, so you have 2 duplicates here now. ID protocol. So it follows the arrangement of your of our TPS file. That is how it is arranged. 1, 2, 3, 4. If you check now, this one is not using FAO like we did in a R. All right, so that has changed. To discover that, if you look at my data here, my fit data here, so that it's using ID1, ID2, ID3. All right, it's not using usual FAO01, FAO02. That is string. Using pure numbers now. The purpose of that so that you can be able to arrange our data accordingly. If not, you will not be able to run the analysis. All right, so let's see how to generate this. So we need the ID protocol, which is I've shown us now, which is according to our TPS file that we have digitized and we have named 1 to 60, 2 replicate. So that is that here. So that was our protocol. You can do that with Notepad as a TST file. Just you need a TST file. You don't need a CSV file like we did before. We called them here now, and then no. Here we just need TST file. Test file. That's what you need here. All right. So just save it as a Notepad. The same thing. Now the second one is protocol. Here, look at it now. So if you look at this particular, this pair, this is called pair. This same pair we did in Excel, it looks like very this, not difference, but there's a little difference here. Now, this is 37, it's 38. Let me bring it up so that I can understand better. Let me browse the one we did before, the shape image. Let me browse it. Okay. Try to locate it. Use just now. Okay, this one. All right. So what I'm trying to say, look at this. Not this. All right. This is. Look at it. Don't forget how we program our stuff. You can see before it's 1. You can see 1 here. Okay. Let's start from 3 here. 37. I see 37. 37. See the same thing. Nothing changes. 1 6. 1 6. Nothing changes. 2 5. Nothing changes. Okay. 4 8. Same thing. 20 22. 12 13. 16 17. 19 21. Nothing changes. That is accurate. But in addition to that one, you know, in R we don't include our midline. Don't forget our midline. This midline. In R we don't include in R, but here you have to include your midline in Sage. So that's the difference between the two now. You have to include the midline. So the midline is what? 9, 10. So you have 9, 10, 11, 14, 15, 18. So in front of another side of midline, you now put 0, 0, 0, 0, 0. That's the formula. So just understand the formula. You'll be accurate. You can get the concept. You are done. So the same way you do for R here, this is tab delimiter. This is tab, okay, tab delimiter TST. So the same way you do for R here, the same way you do for this one. You see the same thing. No file, but it's that file you can save that file here. So that R file you can save it as test file and just open it here very easily. Make it a tab delimiter. That's all. All right. So now we now had what we had here down our midline. Okay, this midline here, mid axis. So we had it here. So we have 9 in front of it. Move 0, 10, 0 because it doesn't have any pair. Okay, it's called unpaired. Because it's unpaired, you include 0 in front of it. Other side of it, 0, 0, 0, 0. So that is how you're going to do for all of them. So this is just what you need. These two files you need, you are done. So let's run our analysis and see what I'm talking about. All right. So now here we browse. We browse here. Let's browse. So let's say where we save our file. I save it here. New R for J object symmetry. So this is my TPS file. So I open it here. So when you loaded, you now click on. Don't bother about the ruler. Just leave the ruler alone. All right. You already. If you don't maybe set ruler, you can set ruler. I don't know, probably you can set ruler to any length you want. But I don't need that. So you can just click. It's loading now. So that's loaded. This is called original data. This is put fit of original data now. All right. So this is what I was saying before. Remember when I was in PowerPoint, I was trying to explain the slide that there's original, that is a reflection or side, and that's the label. All right. So this is what we have now. So here you have 22 landmarks. Don't forget. We have a 120 specimen. Don't forget that is two repeats. All right. So they have been loaded here, this place. All right. So this one is called object symmetry. This one is called matching symmetry. You can see here now. So if I want to do object symmetry, I come here. It's a button. It's a button. You can see it's showing. If I want to do matching symmetry, I come here because it's showing. It's a button. So now I need to proceed. Now I have to click here because I want to deal with what object symmetry. I click here. It will show me to help me to load the two files, the two remaining files now. So I click on the first one. This is called Load Specimen Identification Protocol. So you have ID protocol now. I click on Select. So this is where I'm coming from now. I click on ID protocol. Don't forget what is inside that, because it is the ID of the specimen or the subject you have in the according to the how you have them in your TPS file. Don't forget that. So I load it. If it's okay, it will display say done. If it's not, it gives you error. So alright, so you click on this again, select. Then this is peering protocol. Click here, open. You can see loading peering protocol. Done also. Now click on done here. If you click on done here, it will show here. This is called original red, reflected now blue. You can see that you have original and reflected together here now. You see, this is what you are seeing. Okay, this is what I'm talking about. I think you have forgotten. Let me quickly refresh our memory based on what we have covered so far. Remember this one, this one. Remember this. I was talking about this one: reflected, original, reflected, or side, and the label. You can see original, label. So the same thing we have been doing. So nothing different. All right. So you can look at it here, original, reflected, or side. So this is reflected. Now this is called mirror. This is mirror. Now this dot line is a mirror of this one. It's called reflected. That's a mirror of this thick line. Okay. So that is called symmetry. You only have the mirror. You have the mirror of the same original configuration. The mirror of it or the reflection of it. They call it reflected. All right. This is computed automatically during the analysis, during the generation, the process. Now, when you are done, you now have what is called the label, but that is not part of this. So let us just go back and see what I'm talking about. So this one you can save this and this. All right. Some people may need it sometimes, but I don't need it. So you can save it as original process. For example, now you can just right click on this and say save image. All right. So in our here we save it as what? Original. Right, so you can save as a TIF image, you can save as a bitmap or a hand file, set vector file, you can save as EPS file, JPEG file, paintbrush. So let's save a TIF. Right, so here you can do the same, save here, save image. Let's say reflected and original. These are the standard images that you use for experiment. I mean, for your report. So all right. So now we have done that. So the next step is to now run. If you can get to this place, you are done. So just to run, we have Procus and Alpha here. Run. You can do permutation if you want to permutation. So you can do maneuver if you want to do maneuver, but this is what you need. This one is what you need. All right. So you can do permutation if you want to do permutation. You can in that to increase the number to maybe 999. All right. That time we use 999 there. So if you want to do that, you can do that here, or you can remove it to give you similar answer. If it's not significant, it's not significant. Even if you use 999, it doesn't matter. All right. So just increase it a little bit, not much. So now you want to perform PCA. Now you want to see the variances of those components. You want to see them. So that is why you have to click on that so that you can see the variances of those components. All right. So that is what we want to do now. So let's click on that. Let's click on that so that you can see. So we have clicked on this one, perform PCA of variance. This is important because you want to see the deformation grid, the PCA of each of the components and their percentage. All right, you want to see. So when you select this and you click on run analysis now, so that's the run analysis. I click on run here. So it's running now. It's running. That's finished. That's finished. So now you can see here. You can see the result here. So let's save to file. Let's save to file. You say save to file. We're going to save to file. Let's call the result. So it automatically coming, but don't worry. We're going to open it later. Just leave that for now. All right, come back to that later. So, but let's see. There's more of the options here, but don't worry. This one is very important as well. This particular section, because these are your individual. See individual symmetry. All right, we have DA, that is sides. We have FA, interaction between individual and the side. Okay, and you have error. You can leave this out or this out, but these three are very important. All right, so this view, let me expand this view a little bit so that you can see very well. All right. Okay, so now this place you need to because this is where your deformation is actually. This is we're under individual now, but it may not be very clear. Let's save one and see. Just right click. Let's change the plot set. Let's change the plot setting. Our deformation is saturation factor 1. You can make this one deformation saturation 1. Also 1 is okay. I think 1 is okay. Let's leave 1 okay. Yes. You can see that you can see some blue here. But it's not sharp enough. Let's make it a 1.5. That's a magnitude 1.5. Sometimes this particular grid can be distorted. Sometimes you can change here. You can change this grid density deformation exaggeration here to 2. Sometimes let's look at 2. How it looks like. Look at how it looks like. So if it is distorted, you can now change it to so a lower value, maybe 0.5. But now it's okay now. So let's leave for 1. So if it is distorted, you can hit to 0.5. So 1 is okay for now. Let's save this one and see. Let's save. We call it PC1. PC1 symmetry. PC1 symmetry. Save. Then go to this PC1. What is the value? 29.07. This is what we have. Just approximately 29.06. So this is what is important. We really need this because okay, you can click on save score here if you want to save score. Okay, but it will save as that for you. So let me see. Let me just click on sort. Score. All right, so let's look at what is inside that first. Let's open. See what's inside this course. Okay. We don't need that actually. Don't need that. So let's continue now. Here, this 29.008 approximately for PC1. So look at PC2. We have how many pieces now? 20 pieces. PC2 now, because this guy has changed now. 18.17. So this the variations, the variability of each of the principal components now is what we are looking at now. 18 point. This one contributes 18.717 to the total variation now. The PC1 contributes highest, which is 29.08 total variation to the. So you can save we have saved that one. Let's save the PC2. Okay, 2. Save. I call it PC2 symmetry. This is individual symmetry now. Don't forget. It's what we are dealing with now. So let's look at PC3 now. What do we have? PC3 13.97. All right, 0.97. So let's save that as well. So you have to copy down those percentage. I'm sure this one you have to copy down your note so that you can use it later, because you have to label your PC individually. So we are looking at the PC now. So PC3 symmetry. All right, so let's look at PC4. That one does not change much. You don't see any much variation from PC4. All right, you can see that not much variation. So we have 9.35. All right, let's just save it there. We don't need it actually. Just save it there. PC4 symmetry. All right, so that is for individual variation now, individual variation or individual asymmetry. All right, so let's move on to side, which is DA now. DA is always 100%. All right, that is side because it's one side here. I mean, for when it's side, I mean it's called reflection. Okay, the language you use side here, not because it is a matching symmetry. No, that is language sides. Right. Divide the head into two. You have one side, this side, that is just pair. But now it has 100%. So that is always have 100% actually. So anytime you process, you see 100% for a DA. So what you need, let's change the plot. Let's see. Okay, we're not seeing much here in variability as well. So let's leave it. Let's just save this one. Let's call it DA. DA. There's only one, so we don't need to. It's only one. You can see. So let's go to FA. FA. Let's see. Not changing much. Let's make this one to 1.8. That's it. You can see more if possible. I'm not seeing much. Let's 2.0. 2. All right, that is enough. So let's right click and save this. So this one contributes how much? 27.70 for FA. All right, save. Call it FA1. F1. Then go to FA. You can see FA2. FA2. Don't forget this contributed 12.65%. Let's have one more FA. FA3. All right. So that is what we have now. So this is what you need. You need all these ones, but if you don't need the error part. Error have its own also global error. Okay, we have global error. We have asymmetry error. We have symmetry error. So they're not important in analysis unless you just need anything you want to do with them. So that is what you have for now. All right. So this is how you compute in a Sage very easily. All right. So we are done with what we want to do. We have generated our result here. Okay. So let's go back and see the result what we generated. Go back to our result. Let's see the result. Let's see the result. This result here. Let's click and see from here. Okay, let's see. All right, so let me position this properly. This is FET, SS, DS, DF, MS. Okay, the same thing we have there. So this one is significant. This one is not. All right, so I'm just trying to arrange properly so that you can view together. All right. All right, so you can see now this is having a P equals to 0 and also this one also 0, but this one is 1, not significant. That's it, NS, not significant, right? So for individual symmetry now, it is symmetric because it is significant, and our F is 4.7, which is very high. Then also sides, which is called a DA, is also significant. The F also 13.6. All right, but the FA is not significant. You can see FA is got 0.7 FA for F, and the value is 1, so not significant. You can see it's showing here not significant. But for look at maneuver, maneuver also corresponds with our result we have here in the Procus maneuver. Sides, because sides here is significant 0, sides here is significant also 0. All right, and if by size also here is not significant, 0.5, so not significant. So you can see that you can see the significant components and those one are not significant. So you can copy this out how I'm putting your manuscript or your thesis for an analysis, for further analysis or explanation. So this is what you need for now. All right. So we are going to compare this result together with the previous one we did after we have finished. So we see the result. You compare to see what we get and if they are related or if they correlated. All right. So that is that for now. All right. We'll see you in the next section as we look at a matching symmetry and the same stage. Thank you so much for listening. All right. Bye.